We just finished doing your 2.9B, right? Or you're on the verge of finishing your 2.9B. And as I was just telling Ash, right, you want to look at those histograms. It's why we're making a visual representation. So visually, we're going to be able to see whether or not there's a bias, okay? So as you finish your 2.9B and you roll your die B at least 4 more times, you should be able to see which die is biased, okay? So you need to make a decision. And what are we going to make our decision on? How are we going to make our decision about which one is biased, okay? You want to make sure that you are looking at larger numbers of rolls of die, because the more you roll your die, the more you're going to be able to see where that bias is. So on the right side here of our histogram, of our PowerPoint, we are seeing 2 histograms, and I'm going to make these bigger here so we can see them slightly larger, okay? So notice this is the results for a rolled die 2,000 times, and then results of a rolled die for 2,000 times. So they're different die, right? I've rolled them twice, okay? So when we take a look at these rolled die, which one do you think has the bias? Which one do you guys think at home? Which one of these 2 do you think has the bias? Okay, thank you, Jordan. Same as you guys. Yeah. Okay. Okay, and so that second histogram right there, right? That second histogram is for die B. Okay, I'm gonna leave them like that. That second histogram is for die B. So we can see that there's a spike, right? And we can see it again. This is 2,000 rolls now, right? This is 2,000 rolls, which actually are, yeah, 2,000 rolls, okay? So let's see. We can clearly see, right? It's a much more clear when you have a much larger sample size to work with, because there's a clear distinction on the 3 there, right? So we want to see that sample sizes affect our results. Sample sizes allow us to see the more we roll our dice, the higher our sample size is, the clearer our bias is going to show, okay? So we can clearly see that die B favors number 3 here. Okay, it is biased toward number 3. I don't know. For which one? For this activity? Oh, that's going to be it, because that's the way die B is. So Lamaya was asking, why is it 3? That's the way that die B has been programmed. Oh. Yeah. No, that's the way die B has been programmed. It's not going to change for you guys. It's not going to change. So here's a bit of notes for you guys, okay? The importance of a sample size. And this connects directly back to that idea of variability. Remember, very beginning thing we talked about was that variability, and how sampling 10 people or surveying 10 people is not going to be enough, and the more people you survey for your data, and the more people you collect data from, the more variety and the more accurate your data is going to be in reflecting of your society, right? So the importance of sample size. Sample size gives you that variability, and it allows you to get closer and closer to that idea of probability being the far away amount, that infinite amount of trials, okay? So your sample size needed to be large because the difference between the probabilities of the die rolls was very small. There was a very small difference. It wasn't this giant difference that would be easy to see, okay? So in order to be able to detect, in order to be able to see small differences, you must have a larger sample size. The larger your sample size, the more you will be able to see that difference in that probability, okay? I'll give you guys a moment to finish writing this down. So a larger sample size means a better visible bias, right? Okay. And then the last thing I want to talk to you guys about is your 2.9a homework. Good. Okay. So your 2.9a is your homework assignment for this lesson. Okay. In this lesson, you have a scenario. It says, imagine you had a 4-sided die and you rolled it 20 times. Okay. So a 4-sided die, I want you guys to think about what's the probability of getting each side on a 4-sided die. If a 6-sided die probability is 1 out of 6, right? What's the probability for a 4-sided die? 1 out of 4. Very good, right? Good, Ash. So 1 out of 4 or 0.25. Okay. So for 2.98, as I mentioned earlier, 2.98 does not, you are not doing this in our studio. You cannot do this in our studio because there is no code for a 4-sided die in our studio that you know of right now. So what you're going to do is you're going to imagine and sketch. So you're going to sketch me 3 histograms. And so the first one is you're going to sketch me the ideal probability. Okay. So how many times would you get each number if you rolled that 20 times, right? A 4-sided die 20 times, and you got that ideal probability, the 0.25, right? And then sketch an outcome that's realistic. So obviously we know that we don't always get the ideal, right? We don't always get the same amount for every number. There's definitely variability. And for this one, I suggested one of your classmates, Dario, said that he used a like D&D dice simulator because D&D, they have a 4-sided die. So he just went on there, he found that, and he rolled that die 20 times, and he used that as his realistic situation. And then I said, sketch me a histogram of an outcome that you might see if your die were biased to produce more force. Okay, so think about that. If it's biased toward force, right, how would that histogram look like? If our histograms here were biased towards 3s, right, imagine, look at how we saw that, and then translate that information to a bias of a 4. So obviously, if you have a 4-sided die, your histogram should have 4 bars, right? And you should be working with that. These should be hand done or on Cami, or you print it out and do it and scan it. Take pictures of your histograms and upload it to the document and submit it, okay? So that's it. That's it for lesson 9, guys. I hope that it was fun to do the activity and find the bias, and that you guys had a good time figuring that out.